Okay, well, GeoGebra and GSP will do a lot of this stuff too, but GeoGebra was really built to incorporate a lot of algebraic analytic geometry commands. And so it's really great for subjects like algebra and calculus even. I'm going to do a calculus example. Let's construct a function and its secant and derivative. Find the tangent line and the secant line. Let's use one of our trig functions. I'm going to plot sine. So go down to the input bar. I can just plot sine of x, and that'll plot it and automatically names it f of x. So f of x is sine of x. Okay. We can put a point on that line. We have a new point, and if we drag on top of the line, it'll put the point on the line. So there's the point A, which is restricted to being on sine. Now let's see, what do we want to do? Let's create a secant line. So let's make another point, or let's make a slider first. I'm going to make the point A plus H. Let's start with a slider. I'm going to click on the slider tool, and then I just click where I want to put it on the screen, and it pops up with the little box. So this will be a number. We're going to call it H. Let's let H go from -1 to 1, since H is the distance away from the point and we want that to be small. We're going to increment it by 0.1. That sounds good to me. Let's see. Yeah, I want a horizontal slider. You can change it to vertical. And I'm not going to deal with animation right now, so just apply. So there's our slider. You can drag. I need the pointer tool. I can drag back and forth from -1 to 1 and get different values. Okay, now I want to plot the point f of a plus h. Okay, but when I say that, the point A, I really want to use the x coordinate of that. That's really easy to get on here. On the input, I just do x of a. That's the command to do the x coordinate of the point A. And you'll see it adds it over here. It's 0.38. Okay. And it called it little a, so I can now use that. We can do f of a plus h. And it gave us the value. Okay. Now that just gave us the value. It didn't put a point on the graph. If I wanted to plot that, I would have to do the point where its x coordinate is a plus h, and its y value is f of a plus h. And there's the point. So I have a point that I can take 1 or -1 from a, and I can get it close. Let's get on a more curved part of the graph here. Okay. So now I'm going to plot the line between a and b. I can do that through analytic geometry. I could figure out the equation of that line, or I could just click on the line tool up here and do the line between a and b. It'll automatically give me the equation of that line. So I could do it myself, or I could let Geogebra use its algebraic power to do that. But now we have, if we use the slider, edit, undo. Always make sure you're on the pointer tool before you start clicking on things. We can see we have the secant lines, and as we let h go towards 0, we come in, it disappears because all of a sudden we've divided by 0 on our slope, but we can see we're coming in toward the tangent line. What is the slope of the tangent line? Tangent line is cosine, right? Let's plot the line. Okay, I'm going to use point slope form and do a line that its slope is the derivative at a, so that would be f of a, times x minus, I want it to go through the point capital A there, which has its coordinate being a. And then by point slope formula, y minus y equals m times x minus x. If we solve for y, it would be plus y. Y equals m times x minus a plus y. And the y coordinate of that point is f of a. Oops, I don't want f of a, I want f prime of a. The slope needs to be the derivative there, f prime of a, which is cosine of a, since cosine is the derivative of sine. There we go, we have the derivative. The tangent line, let's change the color. Let's make it blue. And let's make the tangent, the secant line red. And so you can see now we have a construction, and of course it's dynamic. We can move A anywhere we want. And we can see that as h goes towards 0, the secant line becomes the tangent line. So there's a few examples of how I've combined analytic geometry, the algebra components, with the geometry to get the picture here that illustrates the derivative, that cosines the derivative of sine, and that shows me the tangent line.